Hello, my name is Viktor Gamov, and I'm a developer advocate with Kong, and you're watching Kongcast.
Okay. Hello and welcome to this episode of Kongcast. My name is Viktor Gamov and I am a developer advocate here with Kong. We're recording this episode in Atlanta in April of 2022 at the conference called DevNexus. And today I'm super excited here to have my dear friend Oleg Šelajev from Atomic Jar to talk to us something about Atomic Jar and stuff.
Hi.
Welcome.
Thank you. Thank you, Viktor. Hi. I'm very happy to be here, both in this episode of Kongcast and at the DevNexus. It's one of the loveliest conferences, community-driven.
Okay, so in the Kongcast, what our listeners know, we're talking about all things connectivity, all things cloud native, and all things API, and all things developer productivity. Oleg, tell us a little bit about what do you do at Atomic Jar.
So Atomic Jar is a small startup that was created by the maintainers of the Testcontainers Java library. And Testcontainers in general, Testcontainers Java is a Java implementation of the Testcontainers, and there are others for other languages. What the library does, it provides you with a neat API that integrates on one hand with Docker.
Yep.
And it allows you to run, anything that runs in a Docker. It runs programmatically with a flexible API, and the main use case that we are currently seeing for that is to use that in the integration test of your applications. So if you, for example, need a Kafka service and your application needs a Kafka to run, you can, for the integration test, you don't need to set up Kafka externally, but you just need to provide an access to Docker runtime, and Testcontainers will create a Kafka for you, configure your application. On the other end, it will integrate with your application framework, or provide you with the configuration how to reach that Kafka or database, or MongoDB or K3s container or anything that runs in the Docker. And then with the API to create your data schema or provide the proper configuration or the bridge several containers together using the same Docker network. So it's a very, very flexible solution, and it allows you to describe the environment necessary for integration tests from the code itself, so it will never kind of desync between the external YAML files and the code. And it also will assure that your tests are running the same way, whether it's your developer laptop or whether this is your colleagues or whether this is your CI.
Because you're running the same software that you're running. Because you run them in containers.
Yes, you're running code and then you're running containers. So it's all the same, repeatable, isolated, and it's a very, very good solution. And we're seeing more and more people be very happy with adopting this.
I have actually a few questions here. So first of all, for many people, the Docker looks like a black box. Like you run the containers, you do stuff like a Docker run, and for many people, they don't really care what happens behind the scenes, right? Not many people, surprisingly, they know that this actually Docker is sort of like a client-server type of architecture. When you're running Docker, you're actually running Docker client, which interacts with your Docker daemon that runs this, right?
Yes. So there is a runtime that is responsible for running your containers and managing them. And obviously, when you run your Docker pull commands or Docker run something, it's a command line application that will talk to the Docker daemon. You can try the configuration where your daemon is running. It could be local on your machine. It could be somewhere in the cloud, or it could be on other machine. So it will find the daemon and it will pass the command and will pass the credentials if you need to pull something from a registry.
Exactly. Yeah.
And
that's the point.
The proper separation of where you run the commands and where they're executed.
And only the important point to understand for many of our listeners is here that when you're using this client, it's only limited things that you can do there, limited to what you can do by developers of this command line tool. Once you have access to this API, either through libraries like Testcontainers or through the Docker API wrapper libraries that are available for different languages, you can do a lot of things, for customizing all this kind of stuff, or running local stacks. I personally interested in maybe not specifically topic of testing per se, but rather than can we use the technology like Testcontainers to do local runs? So I'm starting my application, and it also will start all these stacks of technologies that my application will depend on.
Well, yes.
In the Kongcast, we're asking tricky questions and we're expecting honest answers.
It's a very interesting question, and there are no easy answer to that. But in short, yes. So how Testcontainers works, it actually wraps the project called Docker Java, which will also our engineers maintain, or at least they partially support and maintain, which wraps the Docker API provided by Docker into a Java code. So now you can control your Docker runtime from your Java code. So you can write whatever commands you want, and then you can run them from a script to give commands, like to pull images and run images and whatnot.
Exactly.
So you can create scripts that will set up your environment as you want, and you can run them either via, like, you can run it as a part of your application, or you can have like a standalone little script, say, for example, using Testcontainers Node.
Yeah.
And you can set up and say like, oh,
that's
because
interesting.
Node is very simple, because you don't need to compile anything. You just write the JavaScript file and you say like, oh, give me a K3s container.
Yeah.
Right? Or give me my Kafka and K3s together, or Kafka in a database and connect them with, I don't know, Kafka Connect or something.
Yeah.
And you can write a script that will do that very nicely without actually relying on running the command line application again and again and again. But you're just pulling the API.
Yeah. Yeah, so and with this regard, the second question is that, okay, so we're talking about a lot of Java. Like me and Oleg, we are Java champions. We've been in the community for a while. And what other people can expect from, like other people, I mean other communities. We mentioned Node communities. We mentioned like, we did mention, but like we always have a Go community in the back of our minds, because it's a cloud native language for writing apps. What they can expect for tools like Testcontainers?
We have implementations for different languages. We have Testcontainers Java was the first, and when it started 7 years ago. Actually, we had a birthday yesterday, 7 years. So
congratulations! That's great.
Thank you.
It's a great thing.
Yeah, it's quite a milestone. So we have Testcontainers Java. We have Testcontainers Go, which is, I think, second in popularity currently. We have Testcontainers Node. We have Testcontainers Python. We have Testcontainers Rust.
Oh wow!
We have Testcontainers .NET. I think that sort of summarizes the most popular implementations that we have currently. The thing is, they're maintained by different community members. Yeah. So it's not just us. The
next question I wanted to ask, like, what's the level of compatibility, level of maturity, different frameworks, like in the different languages?
Yes, they are all working. There are people and projects using all of them. As far as we know. They are indeed at a different level of support and feature completeness compared to the Docker Java. But most of the things are supposed to work, and we would love, at Atomic Jar, we would love to provide more help to the maintainers of those different language implementations. And as the company grows, hopefully we're going to be able to get more hands to help with the different implementations. Even currently, we are trying to make them all on par, but I would expect that they're all usable, and I would expect that there is a lively and like a live community for all of them. Yeah. So there are a number of things. Well, like one interesting thing there is, and just as an example, most of the for integration tests, right? If we are not talking about running your containers once and leaving them run forever, because that's not what you want for integration tests. You want to control the whole life cycle, including the proper cleanup of the resulting artifacts. Like, so when your test run is done, you want to stop the containers. Yeah. You want to clean up the images. Exactly. You want to do that not just when your test passed completely normally, right? But also if something abruptly fails, or the test fail, or everything is in error and everything just crashes, you still want to do the cleanup, because otherwise, well, as a developer, you will eventually...
You either face the situation where you have a like inconsistent environment and you start like seeing like a flaky tests.
Yeah, and or just they will sit there and consume resources, and then eventually your hardware will not be enough, and you will be like...
Or if you're running this in cloud, you will get the build saying, hey, your container is running and stuff like that, right?
Well, with the cloud offers different trade-offs, right? So there is an unlimited scale, but there are, the subscription, like the... Well, it's a paid service. It's a different set. So, like, if you have the fully isolated environments, and your cleanup is sort of on the cloud level. So you just get a VM and then you destroy the VM. Maybe you don't need to like clean up the containers within the VM because you're going to destroy the whole machine altogether. But in general, you want to have a cleanup. So how Testcontainers does the cleanup, we're using the component called Rook, which is the Reaper that it runs. It's a container. It runs. It gets access to the Docker socket, and
it's kind of like a sidecar-ish in the world of.
It's sort of like a sidecar-ish thing, and then it will control the lifecycle of the containers. So even if your test or your process, the original process, kind of finishes, then it can see that, and then it will clean up the resources from the Docker environment itself, and then it will stop itself. So it's a very nice environment. And for example, most of the implementations of Testcontainers use that, and then there's some, because we started this question with how different the different implementations are.
Yeah.
So we are trying, and the implementations are trying to be language idiomatic.
Yeah.
So for example, Java is very big on abstractions and reusing different abstractions. So one thing there, what we have is the concept of modules, where, for example, some like people who know how to run Kafka in the Docker would provide a Java abstractions for that, configure that, know which ports need to be exposed. So as an end user for the integration test, you don't actually say like, oh, run Kafka here, expose my port like 9092 because I need that for the Bootstrap servers, but you just say like, oh, give me Kafka. And Kafka comes with configured properly for you.
Exactly.
So there are modules. And for example, the Go ecosystem.
And the similar, like I have a similar situation when I was writing my the Conc module, where I was like, if you follow this channel, follow this YouTube channel, you know that I'm running this Conc Builders live stream where I'm breaking down like different technologies. One of the things, like I did a few episodes on test containers and how you can use this awesome technology that Alex is describing right now with technology that we built at Conc. And one of the things I found that like I can build a module and share this module with the community of Java or like even Groovy, for example, if you want to write like a script style
like
test.
all JVM languages would work the same. But the best thing because of that, so your end users, the developers who would run and would like to use Conc or test their applications with Conc as a dependency, they don't need to actually have a perfect understanding what Conc needs to run, which ports it needs to expose,
exactly.
how
Just
to.
I want to run Conc.
Yeah. So
with admin API exposed.
Yes. So like to expose admin API, you can offer like a utility method on the say Conc container like object, and then anyone who uses that will just like type the dot and then look at what the IDE provides them, and it will be this is how I enable admin API. Very nice. So as somebody who on the vendor side of the technology, you can embed the best practices of how to test against Conc in the module, right? And
how we solve this in other languages, how people solving it in other places. Because like what I did for Go, I just had a like generic container, and after that, just like I've put everything that I'm putting in my Docker Compose, for example. Yes.
So this is a little bit. So the Go lang, and I'm not a very expert in Go, right? My exposure to Go is a little bit limited, but what's the sort of a philosophy of Go is that a little bit of copying is better than a little bit of abstraction, right?
So and now they still have a generics now.
So for the test containers Go, as far as I know, there are no concept of. There are some discussions about how to introduce modules into the Go. But currently it operates more on the like samples. Description. So if you say I want to run my Elasticsearch container, so you can see in the documentation or in the tests that are a part of the Testcontainers Go project, you can see like, this is how I run Elastic, and I can just copy this and have my Elastic there. And I think it's also a little bit different because Go you build a binary, right? So if you cannot. Like in Java, you can stuff as many things into your application as needed,
and
they will only be initialized and kind of provide an impact when you actually use them. But in Go, you need to build a library. So if you have like 100 different module implementations, that will blow up the size considerably. So this is maybe not the ideal situation. And there are some discussions about how to introduce the modules for the Testcontainers Go, but it's more for the Go community using Testcontainers to kind of figure that out, and from our side, we would be happy to support whichever.
So One of the things that we do at the Kongcast is we asking our guests to demo something, but today it is not going to be like a possible to do in a conference setting. But Oleg, we will with the magic of editing, we will switch to some of the demos. Instead of Oleg would be telling us about all this technology, he will show us about this technology and how we can start this. Oleg, what are you going to be showing to our listeners as after this show? I heard there's interesting thing that I personally interesting because I'm recently started getting the Mac computer.
Yes.
So with the Mac computer, so I noticed that not all images apparently would be translated as is. Kong works fine in the compatibility mode, and we're working right now, actively working on support like ARM native images. But things like Kafka, we mentioned this a few times, it doesn't work.
Yes. So if you get a new Mac, and it will be like an M1-based architecture, so it will be an ARM machine, and not all Docker images have the definitions for ARM.
Yeah.
Which is a little bit sad because you cannot run your test normally there.
It's a bliss in the splendors and miseries of open source, right? It's a good thing that everyone can create this, but it's a bad thing that no one can create this because it's like too difficult.
Yes. So like you actually have and it's not something that is like you need to understand exactly why things are like not working to fix those. So it's not like very easy. And I know other technologies also have some struggles. Sometimes it works, sometimes it doesn't work. I've heard Josh Long from the Spring community. He was
in the Kongcast as well. You can check other episodes.
Yes, he told me that he was some troubles with running MongoDB on his ARM Mac. But one thing that we're currently doing at Atomic Jar, as a product, we're creating Testcontainers Cloud, which is not yet available publicly for anyone. But what it is, it's a cloud version of it's a software as a service version of your Docker runtime.
Okay.
So when you run when you're running your test with test containers, your tests run locally on your machine, but the Docker containers are running in the cloud environment.
Okay.
So you are not using your local Docker, so you're not limited by your architecture or by your resources, but you get like a very seamless integration with the cloud VM, and then your Docker commands are proxied there by a small user space application installed in your machine or in your CI. An agent.
And this is something that you will show the listeners of the Kongcast, I hope.
Yes, as soon as I have my laptop on me, I would love to show it. Do we do this now?
No. We're not doing this now. Like as I said, the Oleg will send me, and we edit this, and you will see this cool stuff. And it's a super bonus for people who are watching us on YouTube. People who don't watch us on YouTube and listen to the Kongcast as a podcast, they will
hear how amazing it is.
They will be jealous because this part will not be included. However,
but in a nutshell, what we're going to do is we're going to install a very small application, and we're going to run it, and then we're going to run the test. It will proxy all the Docker commands to the cloud environment, and there are a number of cool things that we do there. It's an edge deployment, so the cluster where you run your Docker containers is as close to you as possible to limit the latency, but in general it provides you the independence from your architecture on your machine. It allows you to run the test the same way in your CI, whether this is your powerful Mac or it's a GitHub Action runner with one CPU, two CPUs, and a few gig of memory, and you don't have to spin up a beefier workers because. So it's a very cool technology.
We will jump to the demo, and it's always better show and not tell.
Yes. Let's look at how test containers libraries can help you create better integration tests and connect your application to source dependencies like databases, message brokers, and everything else run in Docker containers in your environment. It's an excellent tool, and let's take a look at it in practice. So here we have a normal Spring application. It's a very simple. It just talks about the very basic model of a rating for the talk, and it has a value.
but it has very interesting third-party dependencies, service dependencies. We have a rating controller that talks to Kafka through Kafka template. So when we submit the ratings to the application, they will go through Kafka, and then we have a ratings repository, which stored the ratings in the Redis database, and then the talks repository for the actual talks are stored and is using the JDBC. So it needs the database. There are 3 components there, and we need all of them for the tests. We can run this application if the environment is proper, and we even have some tests here, which we can run. We can try running them, but they will all fail because the environment for this application is not up. So I don't have my database running, I don't have my Redis, I don't have Kafka, and my tests will all fail one by one because my application cannot function. So let's create that environment specifically for the integration test using test containers. The first thing that we need to do, we need to add a bunch of dependencies on the libraries. So we do that using, this is a Maven project, so we just pull the Maven central dependencies by the org test containers group ID, and we're going to pull a bunch of modules. For example, we're going to pull the JUnit 5 integration, and we're going to have a bunch of modules for Elasticsearch, MongoDB, K3s cluster, Postgres, Kafka, all those technologies. The integration between test containers and those comes as different application libraries that you can pull independently. You can pull them on the test scope, but we don't need to do that. We can, if you want, you can use that code in production as well. It could be a good practice. So let's create the environment and explore the test containers API, which is pretty straightforward. The main thing that we want to concern ourselves is the generic container. Let's say we're going to do the Redis first. What we can do, we can say we want a new generic container, and it wants us to provide the Docker image name for this to work. So what I can do, I can say Redis, and then whatever tags we're looking at, Redis 6, what do we have? 6 Alpine probably is good. And now the good thing is the generic container abstracts away anything that we can run in Docker. And of course, it exposes all the configuration that we want to do on a Docker container that we want to. So for example, we can expose some internal ports to our host machine. We can specify which command we want to run if we want to override that. We can specify which files we want to copy from and into the container. They create the environment. All the things that you can do with the Docker container, you can do here without leaving the comfort of your IDE, without doing YAML or configuring it anyhow besides using your favorite programming language. Note that test containers libraries exist in different programming languages. So we have a version for Go, for Node, so you can do JavaScript, TypeScript. There is test containers Python, test containers.NET. So this gives you a very, very nice fluent API for configuring your containers. So for the Redis, I know that we run Redis through network, so we need to expose the container port, and the Redis port that binds, the port where Redis binds on is 6379. This is a little bit of internal knowledge for the configuration that I need to use if I want to use the generic container with any like arbitrary Docker image. Naturally, this configuration can be abstracted away. If I would like to create a library for Redis, I would create like an abstraction called like a Redis container or something, and I will hide this implementation detail for the exposed port in the implementation details. Now we will have the Redis. Now we need to do 2 things. So one, what we need to do, we need to somehow start this Redis thing. So Redis, we have the lifecycle control methods, for example, start or stop, and we can do that manually. We can bind this through annotations to the JUnit test lifecycle. So for example, we can do the test containers annotation on the class, and then the container annotation on the instance field, and then this container will be recreated and restarted for every individual test method we're doing here in the abstract class. But for every test, we would have one new Redis container created, started, stopped, cleaned up automatically by test containers, and for the next test, we will have the new one. A static field will make it recreated only once per test class, but there is totally an integration where you can tie the lifecycle of the containers to your JUnit tests. We're not going to do that. We're going to use this Spring-specific configuration setup here because I want to show you another thing. One thing is to integrate with Docker and be able to run containers and manipulate the containers as you want. The other thing is that for your application tests, what you want to have an integration with the framework. You want somehow to configure your application to use those service dependencies in the containers that you just created, rather than some hard-coded property strings. For Spring, you do that using the dynamic property source method, which will be executed in the test scenarios, and it will configure our application with any properties that we want. So what we can do, we can say registry add, and then say Spring Redis host, and then we'll just create and provide Redis, and that needs to be static. So we're going to do Redis, and then we're going to just take get host, and then we'll do the same with the port. And we're going to take the first mapped port, which is the high number port, which is mapped to the exposed within the container 6379. And in reality, it will be like some large port number because Testcontainers maps it dynamically to avoid any conflicts. If we would like to have two Redises here, we can just totally do that, right? And then there will be no port clashing because on the host machine, we would use random high-level ports. So after this, we just need to start the thing. So we're going to say startable start Redis and join this. And then when the Redis will start, we're going to configure our application. As simple as that. Now, if we want to do, say, Kafka, it's even easier. Kafka container is pre-initialized and abstracted away into the Kafka container class. So somebody who knows how to run Kafka thought about this and Confluent Inc. CP Kafka. I wonder what versions we have here available. 5.4.6. Probably. Docker image name parse. We're going to use the additional abstraction, and then I'm sure content assist will work here. Yeah, we're going to do this. Right. So we're going to parse this Docker image name, full image name, and we're going to feed it into the Kafka container. And Kafka container has the whole bunch of configuration for Kafka specific deployments, how to run Kafka in a Docker environment already abstracted away in the library. So you don't have to think about that. You don't need to know how to run Kafka. You don't even need to know what exactly needs to be configured on the application side. You can just say, start my Kafka. And then you do need to know how to connect your application to Kafka. So for Spring, that would be Kafka bootstrap servers. And then we just do, right? We do Kafka get bootstrap servers. How exactly that URL is created, we don't know, but the Kafka container abstraction knows for us. And you can do all kinds of things, right? So you can do new Postgres container if you want and provide the Postgres image, or you can do new K3s container if you want to work with the Kubernetes cluster, or you can do new Elasticsearch container. All those libraries come from the dependencies from the modules in the Testcontainers ecosystem, and you can use them freely. So we also need a database for our application, and I could have created the Postgres here just like I wanted Postgres container and then Postgres. But I will show you the integration with the JDBC databases. So databases go through JDBC, and Testcontainers exposes a special JDBC driver that will give us a chance to just spin up the containers automatically without any configuration from our environment. So what I'm going to do, I'm going to say Spring data source URL, and we need the JDBC URL, and this is normally JDBC, and then we're going to instrument it with the test containers. And instead of providing URL, we will actually say what Docker image we want to run. So it's Postgres. This is the hardest. Postgres, we say I want to Alpine version for that. And then the database name and anything here, it doesn't matter at all. So what all we need to have is just the container name. Now, when the application will start for the tests, Spring will request the JDBC driver to connect to that URL, and the test containers driver will create the Docker container with the Postgres for us and configure Spring application. So we don't even have to manually create this. Right, let's try to run our tests and see the output for those. It all starts. I will now run the tests. So the Spring creates. We can see that some of the containers are being started. We can see that test containers pulled the images for Kafka that we included and wanted, images for Redis, image for the Postgres database. It is currently downloading Kafka because in my environment there is no Kafka image pre-pulled, but it's very, very fast, and that image will be cached locally. So on the next run, I don't need to pull the images again, obviously, because they are already in the local registry in my machine available. And after that, we can run the tests. You can see here that the database started on the random high-level port, which unfortunately disappears from us. And you can see our tests passing. The test suite here is not the particularly important, but it does talk through the database, and it does send requests to whether the application is healthy, and actually uses the HTTP queries to post the ratings, so it verifies the application behavior. But what I wanted to show you that it's with test containers, it's very, very easy to create the environment, even the most complex environment for your integration tests. And if you want even more complex, you can go there. So for example, you can create the network from test containers and then put different containers on the network. You can build the containers from a Docker file. You can work with them naturally in the application here. You can also run the scenarios which you want. For example, copy file from container if you want after the tests has been running. So if you want any debug files, or you can exec in container if you want to execute a random command in container. It gives you the full flexibility to do anything you want with those containers, and it gives you the excellent API for your integration tests. That was a short demo. I hope it illustrates why test containers is such an exciting and excellent project.
Okay, Oleg, thank you so much for being the part of Kongcast. You learned a little bit about this cool technology. Give it a shot. Give it a try. Maybe it will solve some of the things. Go check the episodes of Kong Builders when I show how you can use Kong with this. And make sure again, if you listen on us using audio, get back to our YouTube channel, watch Oleg's demo. And with this, Oleg, thank you so much for being the part of a Kongcast.
Thank you for inviting me.
And I am reminding you that in this show, we're talking about all things connectivity, cloud, and Kong. My name is Viktor Gamov, and as always, have a nice day.